The triangle ABC is isosceles with AB equaling AC. So AB is equal to AC. So these little lines represent equal length. So an isosceles triangle is a triangle that has two equal sides and two equal angles. So for example, if this side is equal to this side, then this angle is equal to this angle. X is a point on the interior of the triangle. So there's X as a point on the interior or the inside of the triangle, such that the length of BX, so BX, is greater than the length of CX, CX. So the distance from B to X is greater or bigger than the distance from X to C. Prove that the angle ABX, so ABX, so this angle, is greater than the angle ACX, so ACX. So if we were to actually draw in the lines joining B to X, B to X, X to C, X to C, and A to X, A to X, we can clearly see that this angle, so angle ABX, ABX, this angle here, is greater than angle ACX, so ACX, this angle here, but we have to prove it. So I've labelled the angle ABX as alpha, so alpha is a Greek letter, so a capital A and what looks like a lowercase a represent alpha, so I've drawn in what looks like a lowercase a there for our angle ABX. Then for the angle ACX, I've drawn in the symbol beta. So it's basically like the B in the Greek alphabet. So this would be the capital version of it, a capital B. And this would be the lowercase version of it. So angle beta. Then I've labelled the angle XBC as gamma. So it actually kind of looks like a Y, but it's the Greek symbol for G, which is gamma. So this would be the uppercase version, this is the lowercase version, I'm going with the lowercase version. And I've labelled the angle XCB as delta. So this is the letter D in the Greek alphabet, so this would be the uppercase version, which looks like a triangle. And this would be the lowercase version, which looks like a D with a little squiggle on top, so this is known as delta. You don't have to use Greek letters, you could have labelled them as 1, 2, 3, 4. That's up to you. You could have labelled them with symbols. But we do use these Greek symbols quite a lot in maths, so it is good to get used to the names of them. So we have alpha, beta, gamma, and delta. A, B, G, D. So, as the triangle ABC is isosceles, so two equal sides, two equal angles, the angle ABC is equal to the angle ACB. So ABC, so this angle here, is equal to the angle ACB, so this angle here. So then if we have a look at our second sketch, so angle ABC, so this angle here, is equal to the angle ACB, so this angle here. So the angle ABC is made up of angle alpha plus angle gamma, so angle alpha plus angle gamma, and that's equal to the angle ACB, which is made up of angle beta plus angle delta. So ABC is made up of angle beta plus angle delta. So I have angle alpha plus angle gamma is equal to angle beta plus angle delta. So I can bring angle beta over the equal sign, it becomes minus angle beta. And I can bring angle gamma over the equal sign, it becomes minus angle gamma. So I have angle alpha minus angle beta is equal to angle delta minus angle gamma. So as the length BX, so from B to X, this length here, is greater than the side or the length CX from here to here, so the length CX We're told that in the question. We're told that BX is greater than CX. Therefore, angle delta must be greater than angle gamma. So the length BX is here in our shape. And if we think about this triangle at the bottom here, just focus in on that triangle. The angle delta is going to be opposite that side. So the angle delta is looking opposite the side BX. And since the side BX is greater than the side XC of this little triangle at the bottom here, then angle delta must be greater than angle gamma. Because the larger the angle, the larger the opposite side, and the smaller the angle, the smaller the opposite side. So the side BX is opposite to the angle delta, and the side XC is opposite to the angle gamma. So if the distance from B to X is greater than the distance from X to C, then the angle that is opposite the greater side, which is angle delta, must be greater than the angle that's opposite the smaller side, which is angle gamma. So if BX is greater than XC, then angle delta is greater than angle gamma. So what we're going to do is bring angle gamma over the inequality sign. It becomes minus angle gamma. So we have angle delta minus angle gamma is greater than 0. So you keep your inequality sign the same. The only time we ever flip an inequality sign is if we multiply or divide by a negative number. We did not do that. All we did was carry something over the equal sign. So remember, we worked out angle alpha minus angle beta to be equal to angle delta minus angle gamma. So if we got angle delta minus angle gamma to be greater than 0, then angle alpha minus angle beta will also be greater than 0, because we just worked out that these two are equal. So angle alpha minus angle beta is equal to angle delta minus angle gamma. So these two are equal, so they're both therefore greater than 0. So angle alpha minus angle beta is greater than 0. So I can bring angle beta over the equal sign. It becomes positive angle beta. So angle alpha is greater than angle beta. Remember, angle alpha is the angle ABX. So ABX is angle alpha. And angle beta is the angle ACX. So ACX. So that's angle beta in there. So if angle alpha is greater than angle beta, then angle ABX is greater than angle ACX. Angle ABX is greater than angle ACX. And that's what we were asked to prove, that angle ABX was greater than angle ACX. Now I know it probably sounds quite complicated using all these Greek letters. It's no problem at all if you wanted to label them as 1, 2, 3 and 4. It might make a bit more sense for you that way. But it is good, as I said, to get used to the Greek letters because they do come up an awful lot.